All right, folks. So we're back, part 2, chapter 2. We're going to get started, and fun stuff, right? And so I wanted to show you guys this, right? Show this screen because this is going to be the basis as to which we learn the entire CCNA, right? We talked about some of the intro, stuff about computing and what have you, but we're going to start from the bottom up as far as all the chapters go in learning, right? So we're going to start at layer 1. We're going to go to layer 2, go to layer 3, and learn about some other stuff. And at each layer, there's specific standards, official documents by organizations like the IEEE and stuff like that. Do you guys need to know this for the exam? Maybe, right? When I took the exam, you did have to know a little bit of stuff. So the analogies and the high-level breakdowns that you guys got from me in the last session, you won't get it as much because I have to give you guys the actual jargon that's actually used. But again, it'll help you. It'll all come to make sense. And I guarantee you in the future, you'll be like, that's at layer 2 or that's at layer 3. So I hope that makes sense. But let's go ahead and go back to the beginning of the slideshow. So how do I work this? There we go. Let me see if I can. Yeah, I can do that. Okay, cool. All right, so chapter 2, right? So it's going over, we're going straight to layer 2, right? We're gonna, a couple of things that we're gonna cover, and this is gonna be like a 3-week thing that we cover about chapter 2, because it's gonna take a while. A couple of things we're gonna cover, and again, I'm just reading off of the outline for chapter 2 is explain the role and the function of network components. So Ethernet cables, Ethernet connectors, the pinouts, what have you. Explain the actual role of layer 2 and layer 3 switches. Side note, again, I like to call them multi-layer switches because they have the capability to operate at layer 2 and layer 3. So I do not like to call them layer 2 or layer 3 switches, but for the exam, they're going to ask you, hey, is layer 2 switch, layer 3 switch, layer 2, we're at the data link layer, we're talking about MAC addresses, layer 3, we are talking about IP addressing, as you guys remember from the OSI model, chapter 1 section, okay? Then next, of course, one thing we have to achieve within this session, not this session, but entire chapter 2, is describe the characteristics of network topology architectures, okay? One of them being small office, home office, okay? And of course, enterprise environments, what have you. So we're going to touch on that a little bit today. And of course, compare physical interfaces and cabling types. So some fiber, some copper, different type of connections, whether it be Wi-Fi, whether it be a direct connection via wired. So we're going to touch on that a little bit. So hopefully you guys are ready. Again, take all mental notes. And as always, again, I know you guys are multitasking as well. Just feel free to just hear me talk. Feel free to stop me if you have a question, and we'll go ahead and just jump on in. So what we're looking at now, right? As you can see the description of the figure, it's typical small Ethernet, only SOHO LAN. What does SOHO mean, right? Small office, home office LAN. So this is typically what you guys would see, right, at your house, right? So you guys have all the computers and stuff like that hooked up to maybe a switch, right? That you guys, a switch that does Wi-Fi as well and all that you guys maybe bought from Best Buy. It's providing access to multiple devices, right? And that switch has a connection up to the modem or router that you guys ISP gave you, okay? And so typically they all connect to each other, and since the switch, right, in this figure, right, we haven't indicated it or it's not said, but it's typically bridging all the devices in a network together all into one actual group, what they call a broadcast domain, right? Why is it called a broadcast domain? Broadcast domain meaning is if the PC on the left sends a message trying to find PC 3 on the right for some reason that's hanging off of fast Ethernet 0/3, it'll hear it, right? And all other devices will hear it because they're on the same broadcast domain. But we'll touch on that a little bit later. But this is typically how small office, home office looks, okay? That's one of the type of local area networks or LANs look like. This is another one, right? This is just a SOHO with just an access point attached, right? I'm sure you guys seen this before in places you worked at, probably at home or what have you. So hopefully it makes sense. Hopefully you guys, it looks familiar, right? Now, right, what is this, right? So this is a little bit more scaled, right? This is where you guys see at your jobs, or if you guys build labs at home and build big environments, this is what it typically looks like, right? We have a building, we have an office building, right? And we have switches on each floor. They connect to maybe a, and I don't want to confuse you guys with terminology, it connects to another switch, okay? Which that switch connects to a router. But the switch called SWD connects to all the switches, okay? And it's responsible for providing access to the entire building, right? So this is an example of a single building enterprise wired and wireless LAN, right? Because as you can see on the left, they're providing access, wireless access as well on each floor. So this is another type of local area network that you guys, I'm sure, are familiar with and how it's broken down. In the future chapters, future sections, we'll break down how this actually works, the type of architecture, etc. Okay? So here's some data. I'm not gonna go real in depth for the CCNA, okay? I will get my handy dandy writing pad and note take a few things, right? One thing you will have to know, right? I think it says here, key topic, right? Is this right here, right? The types of Ethernet, right? And what it will take you guys looking at it again and again and again and again. You will have to know what that is, okay? So 802.3, and you'll see this a lot if you guys plan on doing more technical stuff in the future. You'll have to know speeds, different nomenclature for this one, right? So if we're talking about, Ethernet, that's 10 megs, right? Or fast Ethernet, 100 megs. Gigabit Ethernet, 1,000 megs, right? And I'm sure you guys seen this already in your workplace, so hopefully it makes sense. You just have to, again, get used to understanding the actual name decorated and given to each, speed and common name by the IEEE, okay? So that's just a couple of things that you'll have to know, right? If I recall, you will also have to know the cable type, right, and maximum length, right? And of course, the actual standard formal name, right? And it can trip you up, right? So one little trick is if you see T at the end of it, it's Ethernet. If you see anything has LX, SX, or what have you, it's fiber, right? So I hope that makes sense. And as you guys can see, that matches up on the right. So just take note of that. And just remember this for the exam. Again, in this first chapter, it's notated as an important topic for you guys to know. And from my experience taking a CCNA and CCNP, they do require for you guys to know some knowledge of this as this pertains to layer 2 in the data link layer, okay? Go ahead and clear all that. Guys, any questions so far? Cool. All right, I'll go ahead and keep rolling. Cool. Thanks, Greg. All right, so let's go ahead. Oops. There we go. All right. So I talked to you guys about broadcast domains, right? The hell does that mean? Okay. You guys heard of local area networks. You guys heard of virtual local area networks, right? What's the difference, right? Local area networks, right? It's networks that are all connected, right? Using they're all in the same group, right? So there's no limitation of a layer 3 boundary, right? So if you see this diagram, let me get my favorite pencil again, right? Since there is no router here or anything in this diagram that says, hey, there's an IP address, limiting the networks, this is all one broadcast domain, right? This is one local area network, okay? You guys heard of VLANs, right? Virtual local area networks, right? And again, I know I'm jumping ahead, but I wanted to make sense because I know you guys already started, you guys experienced so far, you guys know some of the terminology, right? So virtual local area networks, right? As you guys can guess, these are virtual local area networks or local area networks that you can configure on each switch, right? So you can configure certain VLANs here, there, right? Of many kinds, right? And you can actually either assign them to interfaces, right? Assign them to at layer 2 and at layer 3, okay? So for example, clear everything out. Do some color changes, right? This interface, right, is probably on VLAN 1, right? And so, but this interface isn't on VLAN 1. This interface isn't on VLAN 1, it's on a different VLAN. And this is on a different VLAN, right? So these are all different local area networks that you can configure using VLANs, right? So again, a local area network is just a broadcast domain, right? Broadcast domain meaning that a group to where all hosts can communicate with each other on the same network, okay? All right, so, and in this diagram, right, it's going over how the traffic flows, right? Again, the previous 2 sessions I went over, source and destination. I ask you guys that all the time, source and destination. This is how it looks, right? You guys, if, I have a PC and Ryan has a PC and we're all in the same building, we're connected to the same switch, and I want to send a message to Brian saying Happy Pi Day, right? It's going to leave my PC, right? And this doesn't actually happen, but this is just an example, right? Let's say I'm PC 1, Ryan's PC 3, right? I'm sending a message to Ryan, right? What my PC is going to do, my TCP/IP stack that's on my PC is going to say, all right, I know where I have to send to Ryan's IP address, but I need to go ahead and, encapsulate it, right? Brett's favorite word, to prepare it to get put on the wire and turn into ones and zeros. How do I do that? I need to go ahead and put a trailer and a header, Ethernet header and a trailer, turn it into a frame, okay? And with that, it's going to have the source of my PC, and to be more technical, it's going to have the actual MAC address of my NIC card, right? To where that Ethernet connector or the RJ45 connector is plugged into, right? And where it's sitting, right, on my PC. And it's going to go ahead and put a destination to find out, hey, where is Ryan's IP address? Once it does that, and that's called an ARP, right? And we'll talk about ARPs later. But it's going to say, hey, I'm here, and here's my MAC address. My PC is going to get it. It's going to say, all right, cool, I know the destination. I know where to send it to. It's going to go ahead and say, perfect. I'm going to go ahead and I have the destination MAC address. I know where to send it, right? And I'm going to shoot it up to my nearest switch. The switch is going to say, oh, we're all in the same broadcast domain. I know where Ryan sits. I'm going to shoot it out, right? Next to switch 2, switch 2 is going to say, hey, I know where Ryan sits, right? I'm going to go ahead and send it. Switch 3 is going to say, hey, Ryan's connected to me. Send it back down, right? All because, again, that header and trailer that has information about source and destination and all the other things at layer 2, okay? So the real tip that you want to take away from this is Ethernet LANs forwards a data link frame over many types of links, right? Because you see, of course, it's copper, and you got fiber, what have you, so communicate many type of ways, okay? So, but again, remember that this quick point, this is at layer 2. I'm not sending a packet to Ryan. I am sending a frame to Ryan. I hope that makes sense because I'm communicating with him via layer 2. Okay, let's keep going. Let me do that. All right. Okay, here's where we get to the nitty gritty. And I know some of you guys are real technical guys and like to work with your hands. So this is going to explain the nitty gritty of how the communication actually works, right? So basically, if I connect, back in the old school days, if you guys played Xbox or PlayStation and you connected two, video game systems together, this is how they were able to communicate, right? I remember back in the day, I played Call of Duty Black Ops 2. Ryan, I know you know what I'm talking about. And to create a LAN game, right, you would connect them two together via their Ethernet port, and they'll be able to, communicate amongst each other and, of course, be on the same network, okay? So they'd be on the same broadcast. But how do they transmit, right? At a high level, right, it's one pair of wire is, one wire is transmitting while the other is receiving, all at the same time, okay? Some of the wires in the pair, we'll talk about it, is sending traffic. Some of the wires in the pairs are receiving traffic. That's it, right? But all this is happening within an electrical current, right? Those ones and zeros that get on the wire, it's entirely electrical current, okay? That's why copper is used, that's why fiber is used, etc. That makes sense? Okay. So again, breaking that previous diagram down a little bit more and more, right? You guys work with RJ45 connectors, right, which go at the end of these Ethernet cables, right? And using that Xbox example again, if me and Ryan wanted to go ahead and play Call of Duty, okay, I would connect it to my Xbox, right? Since my Xbox is better, I plug into mine first, and then we plug it into Ryan's Xbox, right? But we're all plugging it into the RJ45 port, okay? And of course, what we'll see later is that, as you guys seen previously, or if you haven't, it's all good. There's RJ45 connectors at the end of each cable, right? But there's cables on the inside. There's individual wires inside of the cable, okay? So they both connect, and again, some of them send traffic. They're responsible for transmitting. Some of them are responsible for receiving, right? And the terms transmit and receive are important terms for you guys to understand. When you guys get on the exam, and of course in the future, they may say, transmitting traffic or receiving traffic, etc. So make sure you guys take note of that. And to the right of this diagram, you guys see here's a real life example, RJ45 connector. Here's a NIC, right? So this is how the back of my Xbox look. It has this type of port, right? And here's another example as well. This is just how a switch looks, how those RJ45 ports look. Okay. All right, let's go ahead and clear that. Yeah. Oh yeah, and I wanted to take a little quick step outside of just looking at copper cables. Show you guys, how the fiber cable looks. So, I'm not sure if you guys ever played with fiber, but of course, fiber, all it composes of, it's a long cable, real delicate cable that shoots light out, right, between the actual cable, right? So it's a small fiberglass within the cable that's shooting light out, okay? So it's a really delicate cable. If you ever heard of myself or anybody that you've worked with talk about fiber, that's not a cable we can step on. We can be, it's really a fragile cable, right? It has some benefits. It has a use to go ahead and transmit data over long distances, right? But they do use different connectors or what have you, right? Because they're transmitting light. So they use the SFP, right? Of course, for this, it's SFP plus. And of course, again, it looks different than the RJ45. Here is the SFP port, right? The transceiver goes in there and you plug it in. And again, we'll touch on it later. And once we have our in-person physical lab, and I'll work on that day roughly sometime next month or so, you guys will see, of course, plugging in using a transceiver, seeing how the cable looks and how the light looks or what have you, how that light is transmitted between two devices. So just wanted you guys to take a look at how this looks and just to get familiar with, layer one, how what's used to go ahead and transmit that data. Go ahead and clear that. Any questions so far?
Nah, good info.
Cool, cool. All right, guys. So again, I'm beating a dead horse. Okay, same thing, same thing. And of course, you'll see this whenever you read it. Right? This is a real important piece to learn. I'm going to drill it in your heads. Right? But this drawing is a little bit different. Okay, it goes a little bit more in detail. Right? Take a look at the numbers. Okay, so what does that mean? Right? So again, we're going this way. Right? Traffic is being transmitted, right, on this pair, and then traffic is being received on this pair, right? Okay, we're going down, right? Same thing. We're transmitting on that pair and receiving on this pair. Does that make sense? Right? So there's 8 individual wires, right, within the cable in total, right? The different pairs have different responsibilities, right? So each of them is going to have a different flow of electrical current, right? Again, not really something that you really have to know for the CCNA, but you have to understand this concept, right? Because again, they may ask you something that may be close to this. Say, hey, what's transmitting and receiving, and here's this infograph. Tell me how it works. Okay. Any questions, guys? Okay. We keep going. Whoops. There we go. Okay. All right. All right. So this is the, we're going to go ahead and close out here. I'm going to take my time with this one because this is pretty important. You guys probably should take screenshots, take notes, or what have you. Okay. So you guys seen the different types of, transmitting and receiving infographs, what have you, and how that works, right? And of course, as I explained, some wires, right, within the twisted pairs, they transmit. Some wires are responsible for receiving, right? But in the world of, Ethernet and, of course, computing, what have you, there's been a lot of people that created different things, right, to be flexible, right? So within that Ethernet world and physical world that creates different types of cables, there's 2 types of Ethernet cables, right? And I'll go ahead and break it down and explain it as the book says, right? You have a crossover cable, right? If the endpoints transmit on the same pin pair, or you have a straight through cable if the endpoints transmit on different pin pairs. Okay? What does that mean? Okay, so remember this definition. Crossover cable if the endpoints transmit on the same pin pair. Straight through cable if the endpoints transmit on different pin pairs. The hell does that mean? Let me get this. Right? So, see if I can do this. There we go. So, crossover cable, right? Go ahead and let me use a different color. I think that'll help. One second. Okay. All right. So let's go ahead and talk about it, right? So let's talk about a straight through cable first, right? So straight through cable definition, right, is to where they go ahead and transmit, right, on opposite pairs. What does this mean, right? So pairs 1 and 2, right, they're going to go ahead and be received by 1 and 2, right? But it's on the other way around, right? It's going to be transmitted by 3 and 6. Okay, that's a straight through cable. Okay, right? Now, let's talk about a crossover cable. We have pin 1, pin 2, right? They're going to go ahead and always transmit on these two. I don't care if it's different type of wires on the cable, they're always going to transmit if we're using a crossover cable, right? Hopefully I put it in the most simplest terms possible. Hopefully that makes sense. Does it make sense, guys? And again, it all depends on how you create your crossover cable or how you picked it up. But again, they transmit on different pairs, right? For the straight through, and they transmit on the same pin pair on the crossover. That's it. Okay. And so you guys are probably asking, well, that's a lot of information, right? Again, this is one of the things that they want you to know about, right? They're probably going to ask you 1 or 2 questions about it. Okay. And so with those cables, they have to plug into an RJ45 port, right? And so based on if we're using Ethernet, right, or fast Ethernet, right, this table 2-3, it goes over who transmits on pins 1 and 2 and who transmits on pins 3 and 6, right? So if we look at this, we'll see 1 and 2 are PCs, routers, right, or the APs that we install, right? But who transmits on 3 and 6? Switches, right? Hubs, but hubs aren't typically used, but again, they transmit on 3 and 6, okay? And so, right, so the right way, right, as you guys can see in this drawing, between switches, crossover cables are used, okay? Because they transmit on the same pair, right, 3 and 6, right? Between switches and maybe routers, PCs, APs, is going to be a straight through cable, okay? They're going to transmit on different pin pairs, right? So again, crossover, same type, right? Same type of device. Straight through, different devices, okay? So you guys are probably asking, dang, did I ever use a straight through cable or a crossover cable plugged into a switch and then plug one side to the switch, one side to the PC? So there's this technology, right, called Auto MDIX, right? And it was created and implemented within switches, right, to where even if you use the wrong cable, the Cisco switch will go ahead and notice that you use the wrong cable and automatically, right, or automagically, like some of my mentors say, it'll change its inner workings, its logic to say, hey, I'm going to make this work. I don't care what you used. I'll go ahead and make the cable work. But for the exam, the main thing you guys have to know is crossover cables, same device, right? Switches and hubs. Straight through cables, everything else. Okay? Crossover cables, same device. Straight through cables, different device, right? How I remembered it is, not sure if you guys watch DC or Marvel, right? And of course, there's different shows, right? You got Batman, you got the Arrow, you have Batman, Batwoman, the Arrow, the Flash, all of that's in the same universe, right? If they all had one big special, right? Big holiday special, something like that. That's what they call a crossover, right? Because it's part, and that's how I remembered it, because it's part of the same universe, right? Right? Crossover cables, they use the same devices, right? The straight through cables, right? Maybe we'll call that reality TV, right? That's totally different than comic book shows or what have you, right? So think of the switches as DC or Marvel, straight through cables, reality show, right? But, so hopefully that helps. That's how I understand it. And hopefully me explaining that helps you to understand that whenever you guys take the exam, you guys have to take your time to go ahead and study and make things, just mind map things for yourself so you can remember it on the exam. Because again, it's going to be a lot of questions. I can't specifically tell you how much, because again, it'll put my exam status or my certification at risk. But I believe there will be, based on the PDF, a lot of questions. So take every tidbit that you can get. With that being said, that's it. This is just part 1. There's probably gonna be 3 parts to this chapter, but yeah, this is part 1. We're just getting to the beginning stuff, touching on layer 2 and some of the physical stuff at layer 1. Any questions?
No, this was great. DC
Cool.
shows kind of suck though, but
Oh man, bro, I'm glad. I'm surprised you were deprived of your childhood, bro. I'm sorry, but but all good, man. Okay, so and again, guys, that lab that I sent you, again, it was try to go ahead and get that done before Friday, because we're gonna go ahead and touch on it come Friday. And we're actually gonna do that lab like, you know, during the call. So, but that's it. That's all I got for you guys. I'll go ahead and close this and upload the recording, and you guys have a good day.
take care, guys.
Thank you, sir. See ya.